Alright, let's do a few problems. Um, let's do number one, practice problem 6.2.1. It says here, a resistor allows 1 milliamp to exist within it when a potential difference of 1.5 volts is applied to its ends. What is the resistance of the resistor in kilo ohms? So, current is 1 milliamp, which is the same as saying 1.0 times 10 to the negative 3 amps. Voltage, 1.5 excuse me, 1.5 volts, and you want to have resistance. That's the question mark. Okay, so resistance is futile. V over I, so 1.5 volts divided by 1.0 times 10 to the minus 3 amps. And so this comes out to 1500 ohms, or in kilo ohms, divided by 1000, 1.5 kilo ohms. The others in that group are all the same. They're basically given to find the third. Practice problem 6.2.2. This is just how do you what do you call it? Determining the resistance of a fuse. We'll just do one. So one has a series of 3 red and a silver. Red and silver bands. So the first one for the digit is 2. Second digit is 2. Third digit is 10 to the 2. So times 10 to the 2. I know that's not standard notation. And it's a 10%. 10%. What would they call it? 10% range. So there's two ways you can do this. You can say, okay, 2.3. There's a number of ways actually. Times 10 to the 3 ohms, plus or minus the 10%, or, oh sorry, 2.2. What am I thinking? Or 2200 ohms, plus or minus. You can either do 10%, or you can say what's 10% of that? 220 ohms. And again, the others in that group are pretty much the same. Just a little bit of practice, kind of a bit of fun. Okay. Quick check 6.2.1. We'll do one of these. The others are pretty much plug and play from that wheel that you saw in the last segment. What is the resistance of a 60-watt lamp? So that's power. If the current is 0.50 amps. So this is quick check. Hmm. 6.2.1, and this is on page 234. And what do we know? Well, we know that power, question 1, power is equal to 60 watts. Current is equal to half an amp. And you're looking for resistance. So going back to that circle memory aid, resistance is equal to P over I squared. So power divided by the square of the current. So which is equal to 60 watts divided by 0.50 amps squared. and this will come out to, if you do it right, if I did it right, 240 ohms. Alright? And the rest of them are pretty much the same. You just go back and you find the appropriate equation, and bam, Bob's your uncle. Okay, let's do number 1 from practice problems 6.2.3, and this is on page 236. And it says a dry cell with an EMF of 1.50 volts and an internal resistance of well, this sounds familiar, 0.050 ohms is shorted out with a piece of wire with a resistance of only 0.20 ohms. What will the voltmeter read if it is connected to the terminals of the dry cell at this time? So you're looking for a terminal voltage because it says connected to the dry cells, the terminals of the dry cells. Okay, so what do we know? Number 1, we know that the EMF is equal to 1.50 volts. We know that the internal resistance, the small r, is 0.050 ohms, and the resistance of the wire that tripped everything out is 0.20 ohms. And what you're looking for is terminal voltage, which is X. So the first step, we're just redoing what we did before. Current, got to find current, is equal to the EMF divided by the total resistance of, so the internal resistance and the exterior resistance, which is 1.50 volts divided by 0.250 ohms. Okay, so grab your calculator, and this comes out to 6.00 amps. So that's the current of the whole circuit. So we know that the terminal, or the VAVB is often VAVB, is equal to the electromotive force minus the current times the internal resistance. Well, EMF is 1.50 volts minus the current is 6 amps times the internal resistance. The internal resistance is 0.050 ohms, and this comes out to 1.20 volts. The second one is similar to this one. It's a little bit more involved, but I'm not going to bother doing that because you've got a QR code there that you can scan and get that. Okay? Let me see now. What else do we have here? Okay, review 6.2 is the next thing up. And again, for the first, oh gee whiz, I'm looking up to number 5. Oh wow, they're all plug and play. Just what all that we've been doing. Oh, I'm not even going to bother. You guys are, this is laughing, man. You can finish this up in no time. Awesome. Okay, that's it for me for today. So up is review 6.2, and I will see you in, see you the next class. I'm not sure when that is. But anyway, bless you, and love you. Go away.